Welcome to my report in Fundamentals of Deformable Bodies for Helical Spring. A deformable body is an object that changes shape when a force is applied. Unlike rigid bodies, it can stretch, compress, or twist. A helical spring is a common example because it deforms under force and returns to its original shape. A mechanical device made of wire, typically steel, coiled into a helix shape to store energy, absorb shock, or maintain force between surfaces. Deformation in springs. When force is applied, a spring undergoes deformation, such as compression, tension, and torsion. The shortening, stretching, and twisting of the spring. Two important concepts: the stress and strain. The stress is the internal force in the material, and the strain is the amount of deformation. Springs operate within the elastic limit, meaning they return to their original shape after the force is removed. Hooke's law. The behavior of springs follows Hooke's law, that the strain or deformation of the elastic material is directly proportional to the applied stress, the force within its elastic limit. The formula of Hooke's law is F is equal to Kx. F is the applied force, K is the spring constant, and X is the deformation. Next is the energy stored in a spring, or elastic potential energy. Is the energy stored as a result of deforming an elastic object, compressing, or stretching. A spring stores energy when deformed, so the formula is U is equal to 1/2 kx squared. So U is the elastic potential energy, K is the spring constant, and X is the deformation. More deformation means more stored energy. Applications. So helical springs are used in car suspensions to absorb shocks, machines to control motion, and household items like pens and mattresses. Springs are important because they allow controlled deformation. Importance in engineering. Studying deformable bodies helps engineers to design safe systems, prevent failure, and understand material behavior. Helical springs show how deformation can be useful and predictable. So we know that helical springs are a practical example of deformable bodies. They demonstrate how materials deform, store energy, and return to shape, making them essential in engineering and daily life. You want problems? I will give you 2 problems to practice. So here is the problem. A helical spring has a spring constant of 200 Newton per meter. So if the spring is compressed by 0.1 meter, find the force applied and the energy stored. And try to answer this. So ang problem, ang gipangita niya kay pila ang applied force ug ang iyang U stored energy. So ang given one kay ang spring constant kay 200 Newton per meter. Dayon ang iyang deformation compress man siya, so x is equal to 0.1 meter. So unsa man itong buhaton? Pangitawon tag unang giingon man, pangitawon unang applied force. So unsay formula sa itong Hooke's law, force equals K din X. So sa may K na to 200 times sayang deformation 0.1. So sa makuha 200 Newton. Unsay kuan sa force? Newton. Next, ipangitaon na to ang stored energy niya using energy formula. So U equals 1/2 kx squared. So na naman tayo mga given. K kay pila? 200. Dayon ang x kay 0.1. Then 1 squared. So calculate. So nigawas 1. Ang sa unit sa energy joule. So nakuha nato ang iyang force ug ang iyang stored energy. This is the second problem. A vertical helical spring with a spring constant of 500 Newton per meter is fixed to the ceiling. A 5 kilogram mass is slowly attached to the spring and allowed to reach equilibrium. Number 1. Find the extension of the spring, the force applied on the spring, and the elastic potential stored in the spring. So the gravity is 9.81. So ang gipangita sa problem kay ang iyang extension of the spring og ang force applied, then ang iyang elastic potential stored in the spring. So to stored energy. So ang given niya, duha ra. Ang iyang spring constant nga 500 Newton per meter ug ang iyang mass nga 5 kg, kilogram. Di pa ta pangita sa extension of the spring yung x kay wa matay force, so nahon tong force ug pangita. Unsay formula sa force? F is equal to mg. So natay mass nga 5 kg ug atong gravity nga gamiton giingon nga 9.81 meter per second squared nga 9.81 gravity niya. So atong i-calculate unsay magawas 49.05 Newton force man. Then mana natay force adto na ta sa yang extension of the spring, magamit ang Hooke's law. So unsa may formula gani ato? F is equal to kx. Then naman tay force. So nanatay ani F over k. So tay force na to. Naman toy 49.05 Newton. Then unsa pila yang spring constant kani? So 500. So palagkalkyo equals to 0.0981. Extension man siya, pila sa unit niya? Meter. Next, pagitaon ang stored energy. Nakuha naman nato ang iyang spring extension rito sa potential niya stored in the spring. So, unsa may formula ato? U equals to 1/2 kx squared. So, 1/2 sa may k na to 500 times unsay x 0.981 squared. Kalkyo. Ang gawas niya kay 2.406. Sa unit sa energy, joules. So kita na to yang stored energy. And that's all. Thank you.
Good day everyone. So for today's video, I'm going to report the torsions of rectangular bars. So if the cross sections of the shaft is not circular, experiment shows that the cross sections descend do not remain plane, just like shown in the figure of the deformations of a rectangular bar due to torque T. The two significant features of the deformations are the cross sections become distorted, and the second one is the shear strain, and thus the shear stress is zero at the edge of the bar and largest at the middle of the sides. So the analytical analysis of the torsions of no circular bars lies in the realm of the theory of elasticity, a topic that is beyond the scope of this text. For the rectangular bars and figure shown that the curious torque T results obtained by numerical methods determine that the maximum shear stress tau max and the angle of twist are given by. So always remember that A is greater than or equal to B, or mas dapat dako permi ang A kaysa sa B. So rectangular bar and torsion showing the dimension used in equations, and also that is the length is always given na siya daan to the torque. So the formula of the for solving the tau max is torque over C1 A times B squared. And then for the theta is equals to torque times length over C sub 2 A times B cubed G. And then always remember G is the shear modulus, A greater than or equal to B is cross-sectional dimension, and L is for length. C1 and C2 is the coefficients, and it depends on the ratios of A over B. So this is the table that you will going to be observe or imong basihanan sa pagkuha sa C1 and C2. So always sa imong makita diha is na ay A over B na ratio. So for example, if tagaan ka og 1.7 na A over B or the ratio, and since wala man siya diha sa table, so you need to do the interpolation. So for example, the interpolations of 1.7 or the value of 1.7 sa C1 is you need to do the 2 minus 1.5 since mo man sila ang duha ka value nga in between sa 1.7, and then alpha equals to 0.246 minus 0.231 all over the C1 minus 0.231. And then also is shift solve lang na nimo siya para makuha, since pero kay maglisod man kag shift solve if naka sa ubos ang x, so pwede na nimo siya balihon. So pagbali nimo ana is 1.7 minus 1.5 over 2 minus 1.5 alpha equals to C1 minus 0.231 over 0.246 minus 0.231. So makakuha ka sa value nga C1 equals to 0.237, and also i-repeat na nimong process para makuha sa nimo ang value sa C2. So pag-repeat sa process is 1.7 minus 1.15 all over 2 minus 1.5 alpha equals C2 or x nimo type sa calcu minus 0.196 all over 0229 minus 0196. So makuha nimo ang value sa C2 nga 0.2092, which is correct nga ihang answer is in between sa 0.196 over and 0.229. So now let's have the example. The wooden bar consists of two segments, each length L. One segment has a cross-sectional of width D. The cross-sections of the other segments is circular of diameter D. The working stress for the wood is TW equals to 5 megapascal, and the shear modulus is G equals to 0.5 gigapascal using L equals to 0.6 meter and D equals to 50 millimeters. Determine 1. The largest torque T that can be safely applied, and 2. To the corresponding angle of twist for the bar. So to solve the problem that I am given, so this is the the figure, which is this is the rectangular and also this is the circular. So since same silag length, which is 0.6 meters, so i-convert nato daan siya into 600 millimeter. And then also since pareha naman sila in diameter D, so ang A is greater than or equal to B. So meaning ang A nimo is equal to B, so naglet lang ko og diri o variable D para same naman gihapon sila answer. So first nimo buhaton is less than sa nimo ang given. So we have this the working torque, which is 5 megapascal, and the G modulus nato is the 0.5 gigapascal, and also the diameter is 50 millimeters. So since that we know nga na we have the formula of tau max equals to torque C1 AB squared. So since same naman are equals naman ang A and B na to, so pwede na to siya mabuhat nga tau over C sub 1 D cube. Since ang A ilis na to D, ang B ilis na to D, so D1 times D squared equals to D cube. Since we have also the formula of getting the theta, which is the angle, so we have torque times length all over C sub 2 AB cube G. So kung ato ning ilisan ang D o ilisan og D ang A and B, so mahimo siyang D4, so which is mo na itong new formula nga pwede gamiton. So since duha man ka segment siya, which is na siya circular, so natay circular diri nga formula, which is the tau max is equals to TRJ. So ang J na to is so before na to so since ang T man to pangita so T equals to tau max times G over R. So ang J na to is IX plus YY. So we have the kani nga formula is pi R4 over 4 plus pi R4 over 4. So since ang R na to is katunga siya sa diameter, which is nga 50 mm, so mahimo na siya og 25 nga sitaw na radius. So since naman tayo formula na kani, substitute na nato diri, and then since duha sila pwede nato siya times 2 para malahos siya. So since naka-solve naman ta ani, and also kani siya nga G ato ni siyang gi-store sa A para accurate atong kuha ang answer. So pagkahuman nato solve sa J na natay value sa J, so meaning ana pwede na makasolve sa ato ang T, which is kani. So input lang ni nato ang J diri. So which is ang ato ang tau max is na natay given nga 5 gigapascal. So na 5 times A, which is the J, all over 25, which is the radius of the diameter na 50. So we have the answer of T or torque the 122,718.463 Newton millimeter. So mo na itong torque number 1. Since duha man kapug ato ang segments, so makakuha ta og duha ka torque. So to pag-solve sa usa ka torque, which is ang atong gamiton nga formula is kanina sa rectangular, since rectangular man ang usa. So kani is i-input lang nato largo with, but to get the value of C sub 1 and C sub 2 as always ang atong A and B, which is equal or same as the values of 1. So pangitaon nato ang 1 diri sa table, so we have 1 and then the value of C1 is 0.208 and the value of C sub 2 is 0.141. So since natay value sa C sub 1 and C sub 2 is makasolve na ta diri sa ato ang rectangular tau max. So we have tau na to is mo itong ipangita, so atong i-derive, so makuha natin T tau max C sub 1 T cube. So lahos na atong tau max is 5 gigapascal times 0.208, which is ato C sub 1 times nato sa 50 cube, which is ang 50 nato is ang atong diameter. So ang answer is tau 130,000 Newton millimeters. So sa diri napita, ang atong gamiton ani is nga tau is ang pinakagamay. Kay since dili siya dapat mo violation ani nga working stress nato na 5 megapascal. So atong gamiton is ang kaning tau nga gamay. So mo ni itong answer sa number 1 nga question. And now para makuha nato ang question number 2, which is the angle. So here that kanang pwede nato ni magamit yung formula is ang theta total. So Q1 plus Q2 or equals to torque times length over JJ. So ang J nato is na natay value diri and ang ato ang J sad nga modulus is na nasa tay value. So ang kanina siya nga answer nato diri is nga tau ato na siyang gi-store into B kay para mas accurate gid ato kuha nga answer. So pag store sa B, so proceed na diri sa ato ang formula. So natay formula nga kani torque times length over JJ plus torque times length C sub 2 D for J. So sa imo na siyang sa tawagan na substitution na yung mga given. So since ang atong torque imo na tong store sa B, so B times 600 mm since ang atong length all over A, which is the J nga gi-store to A, and then times atong 0.5 times 3 times 10 to raise to 3. Nanon di times 10 raise to 3 na to, since ang atong G modulus, ang atong modulus is naka gigapascal and then ang atong working stress is naka megapascal. So gigapascal i-convert nato into megapascal, we need i-times lang nato siya og 10, which is 1,000. So next here is same ring yapon ang atong torque is naka-store sa B and then ang length nato is 600 all over sa value nito sa C sub 2, which is 0.141. So times nato sa 50 naka raised to 4 times nato 0.5 times 10 raised to 3. So we have the answer nga kani 0.4071, which is naka-radians. So para maka-convert ni nato into degrees, i-times nato 180 over pi. So nakakuha ta og theta nga 23.325 degrees. So mo na ni atong answer sa number 2 nga question. And that's all for my video. Thank you for watching.